All right, are those the only questions on 3.1?
It's a capital problem.
Oh, we're gonna finish early today.
It's a capital problem.
3.1. Ah! Strike one. Okay, we're on number 17. Okay, so this is just getting used to notation. F of 2 is equal to 3. What does that mean? When x is 2, y is 3. So that's like the point 2 comma 3, right? And then f prime of 2 is equal to 3. That means if you plug 2 into the derivative, you will get 3. So that means the slope of the tangent line is 3, right? Because the derivative is a formula that tells you the slope at any particular value of x. So if you plug in 2 into the derivative, this is the slope. And then of course, once you have that, then what's the equation of the tangent line? Just point slope occultize it, and you are done. Well, I don't even know what the problem is. Let me read it. Write the equation of the tangent line and the normal line. Come on, that's an insult to your loins, this problem. And then the normal line is exactly the same thing, except instead of the slope being 3, it will be negative 1/3 because it's perpendicular to it. Number 20. Find the lines that are tangent and normal to the curve y equal root x when x equals 4. Okay, let's just draw a picture so you can visually see what's going on here. Now this is a base graph. Do we remember what that looks like? Square root of x? No. Oh my goodness. So when x is 4, right here, here's the point 4 comma what? Plug 4 in the square root of 4 is 2. What we need to do is we need to write the equation of the tangent line and then the normal line. So how do I find the slope of the tangent line? Well, I gotta compute the derivative. So then how do you compute the, do we have this memorized yet? This is super important now. Limit h approaches 0. F of x plus h, you substitute x plus h into the function, minus f of x, which is the function, and then divide the whole critter by h. And then, oh, 0 over 0, what do I do? Radical. Rhymes with multiply by conjugate. So multiply top and bottom by the conjugate. So when you multiply that, you're going to get x plus h minus x. And the x's cancel out. The h's cancel out, so all you're left with is with a 1 on the top. Now can I plug in 0 for h and get something? Yeah, you're going to get 1 over root x plus root x, which is 2 root x. That's the derivative. That's what's going to tell you the slope of the tangent line. So how do you figure out the slope of the tangent line when x is 4? You simply plug in the x value into the derivative and you get 1/4. So then just point slope occultize it. Y minus 2 equal 1/4 x minus 4. And then to do the normal line, you do exactly the same thing, same point. Because the normal line goes like this, yeah? Just make the slope negative reciprocal. See how easy calculus is? And you know what? After tomorrow's lesson, we don't even do the difference quotient anymore. We just look at that function and we go straight to that. But then you gotta learn some shortcuts. But then if you took PCH last year, do you guys remember the shortcut? How do you know? You read ahead. You have friends in BC. We learned the secret. Never mind, we'll learn it tomorrow. Anyway, you can't use the shortcut yet. So on the next quiz, which will be, when is the next quiz going to be? Monday maybe? it's gonna say, use the definition of the derivative to compute the derivative. So if you just write the answer down, that's like -4. If it just says find the derivative, then you can just find it. But I'm telling you right now, it's not. All right, 22. Ooh, very interesting that these are all even problems. Not interesting, fishy, that's what it is. Graphing, we went over this before! Didn't we do this yesterday? 1, 2, 3, 1, 2. So here's the graph of a function. Let me see if I can graph this correctly. Yeah. Sketch the graph. Are you teasing me? Sketch the graph of the derivative. Okay, what's the first thing I told you to look for? Where is the slope? 0. So the slope is 0 there and there. So at these values of x, like right there, you plot 0 because the derivative is the slope. Right there. Did you guys do that? Anyway, you guys, how many of you are taking AP Econ? Don't you have to deal with slope a lot? The slope of the graph? Yes. Okay, here, you can impress your teacher then. Did you guys talk about marginal revenue? Or you guys use the word marginal? You know what marginal means? The slope or the derivative of what? So marginal revenue is simply the slope of the revenue graph or the derivative of the revenue graph. See? And maybe your teacher didn't use that word because maybe most of the people in your class are not taking calculus, that's why. But you are, so now you have a distinct advantage over them. So you dominate them. Okay, now pick a point. So you got, here's the 2 zeros. Pick a point here, here, and here. So like, think of a point here, like right there. Go up to the graph. Here, pick a point right there. Go up to the graph. Is the slope positive or negative? So plot some positive number. It doesn't matter what positive number. Now pick a point in between these two. Like how about at 0? Right here at 0. What is the slope? It's negative. So plot some negative number. And then pick another point out here, like right there too. What's the slope? It's positive, so plot some positive number there, and then connect the dots. You guys know how to do dot to dot, right? So something like that. So did you get something that looks like that? Yeah, that's all you gotta do. Because all we're doing is sketching. We're just sketching what the derivative looks like. We can't get it exactly because we don't know what the exact function is. Oh, another even problem. 24. Shown below is the graph of x ln x minus x. From what you know about the graphs of functions, pick the one that is the derivative of this. So you're going to do the exact same thing, except now you got to know your base graphs again, which of course is a problem. Okay, how do you graph the derivative of something like that? First, what do? You look at where the slope is 0. Right there, the slope is 0 right there. So you plot 0. Okay, now pick a point somewhere on this side, like right here. What is the slope? I'm not going to draw anything in because you guys can see it now. Like right at this value of x, what's the slope? So plot some negative number, doesn't matter where. And then pick a point somewhere over here, like right there. What is the slope right there? Positive, so plot some positive number, and then connect the dots. Okay, what graph do we know looks something like that? Let's look at the choices they have. Does sin x look like that? No, well, first of all, sin x goes through the origin, right? So then that's out there. What about natural log x? Yeah, it looks like it. But then let's just go through the others just to make sure. Root x? No, root x again, that goes through the origin also, so that's not it. What about y equal x squared? Does that look like y equal x squared? Get out of here. And what about 3x minus 1? No way, so it is natural log x. Anyway, like I told you on the next quiz, I'm going to ask you to, oh, they didn't have it here, but I think it's on tonight's homework. Remember that thing I told you, you have to graph the derivative on your calculator and then you have to try and guess what the original function was? We did this, were you guys here 24 hours ago? Yeah. Physically? What, there was a lab due or something? Bio lab due?
It's tomorrow.
Tomorrow.
The lab is due.
Yeah, we have a test. We have an exam today. Tomorrow.
What?
But let's just memorize what you read, right?
No, it's harder. She needs to actually take it so hard.
But then what about the lab? I remember last year when the bio lab is due, then they just do it last minute and stay up all night, huh?
Yeah, well, that's tonight.
That's tonight.
Why? What? Did I even start the video? Oh, I hope so. If not, we'll just take the next class. Okay, what number are we doing now? 25. From what you know about the graphs of functions, pick out the one that is its own derivative. Okay, so let's go through these one at a time. Y equals sine x. Okay, so let's draw sine x. Okay, that's just one period, okay? What would the derivative look like? Like where is, first look at where is the slope 0? There and there, right? So there and there. And what about over here? What is the slope? Positive, so plot some positive number. What about in between here, like right in between? What's the slope? So plot a negative number, and then what about like right there? Positive slope, and if you connect the dots, it's kind of like this. Is that the same thing as the graph? No, in fact, we did this yesterday, right? Wasn't the derivative of sine x cosine x? Yeah, so that's not it. So why did we even do it? Next one is x. Okay. What does the graph of y equal x look like? That's a duh. Now, whenever you have a straight line, the slope is always the same. What's the slope over here? 1. What about there? It's 1. It's 1. It's 1. It's 1. It's 1. It's always 1. So that's why that's what the graph of the derivative looks like. It's just 1, 1, 1, 1, 1, 1, 1. The slope is always 1. So that's not the same graph. So then we move to the next one, which is root x. Ooh, this looks interesting. Okay, so here's the graph of root x. Where is the slope 0? I don't see any place where the slope is 0. So like, what would you say the slope is like right there? Look, the thing is coming down like that. Maybe I should draw it a little better. It's like this. See how it's approaching verticality? So like right at 0, the slope would be like vertical, but what's the slope of a vertical line? Rhymes with undefined. It's undefined, okay? But what if you were to plot the slope very close, like right there? Would be a really big number, right? The slope would be very steep, so it would be big. And then like right here, what is the slope? Like maybe that would be like 1. And then what, is the slope getting steeper or smaller? Yeah, so then like over here, the slope would be like 1/2. So if you connect the dots, it would be something like that. Now does that look like the original graph? Don't be ridiculous. And then the next one, e to the x. Do we even remember what e to the x looks like? I hope so. These are all base graphs. Wow! Okay, is there any place where the slope is 0? No. So, like right here, what does the slope look like? It kind of looks like 1. And then right there, is it getting steeper? Yeah, so it's got to be bigger than 1. So you plot a number bigger than 1. And then like over here, what about there, the slope? It's positive, but it's much smaller than 1. So you plot, connect the dots. Yeah, it looks like the same graph. But then, let's just do the last one for good measure. Y equal x squared. That's okay, because this is good practice. You guys, no, I'm serious. This is a skill you have to have on the AP exam. They always ask you this question. Sketch the graph of the derivative. You have to do that. So where is the slope 0? Right there, right? The slope is 0 there. What about there? It's some positive number. And then what about like here? Some negative number. So right there, you plot a negative number. Connect the dots. That doesn't look like the same graph, so that's why the answer is the 4th one.
Wow.
I'm not gonna give you a problem like that. It's gonna be like this. I'm gonna give you a graph, like this, a nice polynomial, you have to sketch the derivative. You're gonna get it on the quiz, you're gonna get it on the test. And you're also gonna have this one. No, well, we'll just get there. I'll show you another one after. 26B. 26B, what is A? What? Wait, see, this is a dumb problem, B. At what values between -4 and 6 is the function not differentiable? Do you guys even know what the word differentiable is? You know why? You know why? That's today's lesson. Though. 3.2 is differentiability, where we're going to define the word differentiable. That's why you can't do the problem. So you know what? Why don't we do today's lesson, and then we'll go back to that problem and answer. Did anybody look up the word differentiable on Google or something? Oh? Just wondering. Did you guys bring your graphing calculator today?
Yes.
I did.
Okay, so in honor of that, let's do a problem. Let's practice for the quiz. You're gonna get problems on tonight's homework. I thought it was on last night's homework. I'm going to give you the graph of a derivative. What am I saying? I'm going to give you the graph. Oh yeah, I'm going to give you the equation of a derivative. You have to, and you graph it on your calculator. You got to tell me what the original function was. I hope this is not the same as tonight's homework. Well, let me look at tonight's homework. I don't want to give you the same thing. It's boring otherwise, right? Where would that be? Where would that be? What? Or did you do it on last night's homework? No, you didn't. Okay, here. Oh no, I see it. Okay, here. Y equal natural log absolute value of sine x. Graph the derivative of this. You guys remember how to graph the derivative of this? So we got a y1 equals d over dx, natural log, absolute value sine x, x equals x. Woo!
Oh, there you
Where's the absolute catalog?
No, go to catalog. Abs a math, the
Okay.
math button, isn't it right there? Or num then, num, math num.
Okay.
And where's the absolute value for the Casio?
Option numeric.
Option
Numeric.
numeric. Also, it's the same thing, num. Anyway, if you have math print, it's gonna come out like that, yeah? That's because it's computing the slope at every point and then plotting the point, computing slopes. And let's graph this in a zoom trig, V-window trig. 2 pi. So if you did it correctly, did you get something that looks like this? I guess your calculator goes this slope, like that.
Yeah.
Because it's computing the slope at every. Or is it faster than that?
Yeah.
Okay, sorry. Why am I saying sorry? So it's graphing it, and then it looks like that. And then you go, hey, you somebody. Tan, go to your room, tangent. That's cotangent.
Go to your.
So the derivative of this function, our guess would be y equal cotangent x. That would be your guess. And you know what? You would be correct.
X. You know, it's derivative x. Where does that x go?
Because that means derivative. You're graphing the derivative of this thing, and you're trying to guess what the derivative is. Okay, can everybody get this on the calculator? Because this is going to be on the next quiz and on the test. Yeah?
Wait, it doesn't really look like that.
And deriv, natural log, absolute value. Oh, you need one more parenthesis. Yeah. After the sine x.
Mine didn't look out like that.
Let's see. Derivative of natural log, absolute value sine x at x comma x. You're in degree mode.
Hmm.
Cam? That's a bozo no. Did everybody get that? Who doesn't have that? Well, of course you're free. I keep telling you guys, leave your calculator in radian mode, and then when you do physics, just put the degree to override the radian. I'm not listening to you, Mr.
I
Bart.
also don't know where the degree button is, so
Angle.
I don't know.
If I come over there and I see the angle button,
Oh.
and look, you didn't even do a zoom trig like I told you to do. It's like trig 2, Cam. Zoom trig. Don't worry, on the quiz it's going to say draw the graph in zoom trig. I guess and then I got to put v window trig also there. No, the reason why you do that because it goes from negative 2 pi to 2 pi, and then you know you guys can recognize trig functions, right? Okay, now today's lesson super easy. Did you guys bring your book, or should I even bother asking? Did you at least take a picture of it?
Yes.
Not the book, but the pages that we're going over. Not just the problems, the text. You guys are. What would happen? Are you guys taking like? Never mind. Never mind. What do you other? What? Okay. What if you're taking an English class, AP English? Who has Dr. Lagori? And you're discussing a book and you don't have it. What's going to happen? He gives you a book. He gives you a book?
It's all the text on the course
Never mind.
Another good example.
Okay, this word differentiable. This is what we got to know today. What does this word differentiable mean? Because they're going to use it over and over and over on the AP exam. Basically, differentiable means the derivative exists. That means there is a tangent line. The slope of the tangent line exists. The layman's term for differentiable is just smooth and continuous. Okay? So if a function is smooth and continuous, we say that it's differentiable. So like, okay, let me give you some examples. Is this function differentiable at x equal a? Yeah, because look, right there, it's smooth and continuous. You guys know what smooth means. There's no like sharp points or, and then, what did I just say? Oh, continue. You guys know what continuous means now, right? There's no breaks in it. Okay, now what about here? Let me give you another example. Here's b. Is this function differentiable at x equal b? No, because it's continuous, but it's not smooth. Anyway, we already learned, right? Whenever the graph comes to a sharp point, the derivative does not exist. There is no derivative. That's because the left-hand slope and the right-hand slope are two different numbers. Like over here, see how the left-hand slope and the right-hand slope are the same? That's what makes the graph smooth. The left-hand slope and the right-hand slope are the same. Okay, here's C. Is this function differentiable at x equals c? No, because is it smooth? No. Is it continuous? No. It has to be smooth and continuous. Okay, what about this then? Is this function differentiable at x equals d? No, because it's not continuous. It has to be smooth and continuous. No, because it's how can it be smooth there if it's not even continuous, right? So it has to be continuous first. So in order to have any pair of being differentiable, it first has to be continuous, but then it has to be smooth. Like right there, it's continuous, but it's not smooth. That's because the left-hand slope and the right-hand slope are two different numbers. And that's what differentiable is. It's that simple. And then and see, that's the whole lesson right there. So now let's go back. No, that's why this is like the easiest homework of the year right now. Today's lesson. So if we look at, go back to number 26 on last night's homework. Did you guys get part, did everybody get A? Because I taught you guys that yesterday, right? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2. And then 1, -2. Whoop. And then 4, -2. Whoop. And then whoop. Okay, this is what the graph looks like. Okay, do you want me to do part A since I have it on the board? Just do it. Look, it's an even problem. That's right up your wheelhouse, right? Putting even problems on the board. Okay, I'll do it. Okay, now when you have lines, it's simple because the slope is the same. The slope stays constant. Like, okay, what's the slope of this line right here? Look, rise over run. 2 over 4 is a half. So that means the slope is always a half. See, like, look, it's just half, 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 half. Half, 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 half. It just stays half. But then right there, you gotta put an open circle because, how come I gotta put an open circle? Because there's a sharp point there, there is no slope. The derivative does not exist at a sharp point. Okay, what's the slope of this line right here? What is rise over run? 4 over 2, but it's going downhill, so it's -2. So what's the slope? -2, -2, -2, -2, -2, -2, -2, -2, -2, until you get there, open circle. Now what's the slope over here, where you have a horizontal line? 0. So here, put the open circle there, 0, 0, 0, 0, 0, 0, 0. And then what's the slope of this line? Rise over run. 2. So open circle because sharp point, and then 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. And there you go. That's what the derivative looks like. The derivative is simply the slope of the graph. That's why when you have lines, it's easy, because the slope stays constant throughout the line. Okay, now let's answer the question. At what values of x between -4 and 6 is the function not differentiable? Now we know what differentiable means. That means the derivative exists. It has a derivative. It's smooth and continuous. So look at this, this white graph. Where is it not differentiable?
At the points.
Yeah, when you have sharp points. So where would that be? When x is?
0.
No, it says between -4 and 6. Between
0.
means it doesn't include.
0.
So 0,
1.
what?
2.
2
4.
and 4. 0, 2, and 4. Because you have sharp points, the derivative does not exist there because it's not smooth and continuous. See how easy that was? So I believe we're done already. Let me look at these problems that you have to do tonight. This is just ridiculous. You can do this homework in like 5 minutes. Okay? Well, I'll give you the rest of the time, then you guys can. So tomorrow, we're gonna learn shortcuts for finding derivatives. So tomorrow, you're gonna come to class, and I'm gonna teach you, like you have that. What if you have to find the derivative? Well, the only thing we know up to now is you gotta use the difference quotient and take the limit as h approaches 0. But tomorrow, you're gonna be able to look at that and go, -1 over x squared. Wow. See, that's a preview, that's like the trailer for tomorrow. It makes you want to be in class tomorrow, yeah? Or you could read the book. Does anybody even read the book? Who reads the book? Nobody.
Never read the book.
Really? Ever? In any math class? What do you do? Okay, let me ask you this.
So you're gonna teach it.
No, but okay, when you go to college, yeah, when you go to college, what's gonna happen when you you take a math class and your math teacher, yeah, Indian, Russian, or Chinese?
You go to your free tutor.
You read the book.
You go to the
That's what you do.
YouTube has really good
Huh?
tutor stuff. YouTube. Like if you don't know how to do something, Google. YouTube or Google.
How about read the book?
But it's so,
Just
that's
stay on
great.
time.
It's so,
Okay, please let this have been recording. Please, please, please. Please. Is it going? Yeah, it was.